Okay, we should be live. Okay, so thank you for joining today. We are from C4. We've got our Certified Ethereum Professional Committee with us and special guest Jake, and we're going to do intros in a second. But first, we're going to be talking today about Ethereum Account Abstraction, which is a very exciting, new, and interesting topic. We're going to be talking about what are accounts in general and why do we want them to be abstract and some of the details surrounding this. So let's do intros first. I'm Jessica Levesque. I'm the executive director at C4. And why don't we jump over to you, Josh?
Sure, I'm Josh McDougall, one of the founding members of the board of C4 and a very proud member of the Certified Ethereum Professional Committee. And in my daytime, I create video games in the space. Kent?
Hey guys, I'm Kent Barton. I'm the founder of the Ethereum Denver community, and I've been in crypto a while. Also a proud member of the CEP and co-authored the CEP study guide with Jessica.
I'm Dustin. I'm based in Singapore and I'm a C4's education manager. And also work with a local community called E65.
All right, special guest today. We have Jake. Jake, will you do a quick intro?
Yeah. Hey, I'm Jake. I'm a developer on the Walled Accounts Experiments project, WAX, as we refer to it, at Privacy and Scaling Explorations. We're primarily focused on doing experimentation on top of smart contract accounts, with a focus currently on integrating kind of novel cryptography or zero knowledge proof kind of technology into the smart contract account ecosystem, with the intention of trying to essentially improve the functionality of accounts and try to make it so they're usable by people no matter who or where you are. So very excited to be on this call to chat about account abstraction.
Awesome. And that's kind of, I think, a good segue to start with. I think, Kent, you were going to explain to us why we're talking about account abstraction today, and it relates to what Jake just said in terms of functionality.
For sure, yeah. So let's kind of put this, let's zoom out and put this in the context of everything that's kind of happened in Ethereum recently and why we're talking about this. So if you guys have tuned in recently to CEP live streams or you've just been paying attention, a lot of this stuff has been around scalability and making rollups cheaper to use. Those improvements have been rolled out. We've talked about, proto-dank sharding and all this stuff. And that's a super crucial aspect of Ethereum, making it more cost effective, making it cheaper. However, there's kind of a related thing. Ethereum has been criticized for many years, and I think rightly so, that its UX kind of, in some ways, has not been great. Some people might say it sucks. Maybe that's dramatic, but there's certainly room for opportunity. So to date, users have, or actually until the advent of account abstraction that we'll get into, users have had to put up with some difficult problems. One is just like simple, managing your wallet. What happens if you lose your keys? If you've used DeFi or a lot, or other dApps, decentralized applications, you've had to deal with constantly reaching for your wallet or clicking on your wallet to approve tokens and make these approvals, and you kind of gradually get used to it. But for people, if mainstream adoption is going to happen, we need to solve for that. Things like gaming are a problem. It's it's always interrupting the UX, and then finally, things like gas. Gas is a core element of using Ethereum. That's not going away, but the requirement to have gas or have ETH to pay for transactions is difficult. So what does this have to do with today's topic? Account abstraction is a way to, as we'll see, address all these issues. It sounds kind of like a technical and almost abstract term, pardon the pun there, but it really is. Once you understand it, you'll see how powerful it really is.
Yeah, that was a great intro. I think maybe what we should do now that we've got this broad picture of why we're talking about this is to explain what externally owned accounts are, or EOAs. Who wants to jump in to just give a general overview about what EOAs are and maybe versus smart accounts, and just kind of get into, or sorry, smart contracts, and get into what the different account types are?
Yeah, I'd be happy to jump into that. So within the kind of Ethereum, within Ethereum, we have kind of two kind of accounts that are allowed. One is an externally owned account, which is going to be very similar to accounts you would see on a lot of other blockchains, including things like Bitcoin, Litecoin, Doge, etc., going out. And these accounts are essentially asymmetric keys. So you have a public key and a private key. And the address for that account is going to be essentially a hash of that public key. These accounts, and so essentially that key is the account. And so we then, sign transactions using that private key, and then the chain uses the public key to verify that this account is authorized to do that. And so, yeah, and then also in Ethereum, smart contract accounts are also smart contracts are allowed to essentially control funds as well. And because the what you can actually do to call into a smart contract can be very widely, there are a variety of ways you can essentially authenticate and authorize that someone is able to, say, move or control funds or, say, an NFT from that smart contract account. And because of that flexibility, there's just a wide variety of things you can do. One of the biggest issues with externally owned accounts, as people know from, say, having private keys exposed on the internet, or, say, losing them in a hard drive in a garbage dump, is that once you lose that key, it is, or someone sees it, you've essentially lost access to that account. And so in addition, you are limited with those accounts to whatever specific signature scheme and cryptographic curve is used. So for Ethereum right now, it's going to be ECDSA, and it's going to be, I believe, the CEP 256K1 curve, I believe. And so, which is the same as what's on Bitcoin. And so essentially, you lose that key, you lose everything in there. So one of the things with smart contract accounts, because we can vary those authentication and authorization patterns, you have a lot more flexibility to, say, rotate keys, or, say, limit what those keys can do with that account. So even if you do lose it, maybe you only can lose some funds. And so that's kind of the big difference between those, is you have an EOA which functions much closer to, say, hardware, where it's fixed and does not change. And then you have a smart contract account, which is much more flexible, similar to software. And so you can reprogram or change it.
Okay, awesome.
A lot of our, some of our viewers might have actually used smart contract accounts and not even really realized it. If you've ever done anything multi-sig in the Ethereum space, it's probably been using a smart contract that handled the multi-sig elements. So there's been kind of classic versions of that in the space that many people have interacted with. You were interacting with a smart contract abstracted account of your own accounts together with a group of people. This is, kind of moving towards doing that concept for a single person as well, and what kind of value that brings you as an account holder. But there's all sorts of different use cases for it, which I'm sure we'll get to.
Yeah, and I wanted to also bring up, we're talking about private keys and why account abstraction is so important related to private keys. So I thought maybe we could do a quick poll. Who here has either screwed up a private key or seed phrase, or knows somebody who has, which has caused the loss of funds or assets in some way? You don't? Yeah, okay. So we recognize this is a problem, and this is why we're talking, why the Ethereum community is talking about how to make improvements on this, and why this is such an important topic, because like Kent was saying at the beginning, we want to improve not only UX, but also user experience in general. And this all ties into that.
Sometimes it's not even like an urgent emergency, horrible situation. I had a MetaMask browser wallet going on. Great, it does the job. Then, it gets a couple NFTs in it, more stuff. It gets access to a bunch of things. And eventually you think, you know what, this should probably be on a ledger or something like that. Some sort of hardware wallet or a different system. So then you set up the ledger, and now you've got two wallets. Now you've got this MetaMask wallet and your ledger wallet. And you basically have to play this game where you monitor gas fees for the next year or 2 years before you can get all this stuff moved over to your new wallet. And you end up really just never doing it. And you end up having two wallets that you then use interchangeably. So being able to move assets, move all of your stuff en masse would be such a nice benefit to have. And if this technology had been there, in the first place, then we wouldn't really have these problems.
Yeah, that's such a good point, Josh. Okay, so should we talk a little bit more about the UX, the original sins of UX, and get into a little bit more why this is so important? Did you want to talk a little bit about that, Dustin, in terms of token approvals and things like that, and gas, kind of maybe adding on to what Josh just said?
Sure. So I think one of the things that, like, as a new user to crypto, whenever you come in, the first thing that confuses you is that, like, I'm about to send a transaction. Why did they ask for like this approval? Why did I have to do it twice? And sometimes you're like, did I do it wrong the first time? Only after a while do you realize that you need to approve a token before you're allowed to, send it to a smart contract or do a swap or whatever it is. And the token approval gives, the smart contract access to that. And some smart contracts to make it more user friendly, they ask you, do you want to just approve the entire balance of this token? Because then if you approve it once, you don't need to approve it again. Unfortunately, what that means is that if you have 1 million of this particular token and the smart contract wallet for better user experiences, approve all of it. And then you approve all of it, even if you did a swap for $100, you still approve the entire balance. So if there's any compromise that happens in between, then they have the approval already to swipe the entire balance. So there are lots of problems with token approvals, and one of the things that you can solve with that is, like, you do the exact approval for the amount that you're swapping. But then that means every time you swap, you got to pay gas for an approval and then the swap. So there are multiple reasons why people do approve all, because it's better UX, it's less fees. But then the problem is you've got this open approval. Otherwise, you have to do your swap, and then when you're done, you close the approval, which is another transaction. So these are one of the problems of token approvals, which can be solved, which account abstraction can solve, and I'll leave the Jake to tell you how that can be solved. But there's also the problem of having gas, which is like, okay, you have an Ethereum wallet now, start doing transactions. Oh, you need ETH first. So, like, where am I going to get ETH from? Someone needs to send ETH to you. So there's the concept of someone being able to sponsor a transaction from you using something called a paymaster, or meta transactions. There are different ways that people can pay for you, and account abstraction can kind of enable ways for other people to pay gas for you. The other part of it is like the gas cost of individual transactions, um social recovery and things like that. Some of the original sins of EOAs can be kind of defrayed by multiple ways that account abstracted wallets are able to do it.
Jake, did you want to add anything to that you think is useful for the viewers to know about these original sins of Ethereum UX, as we're calling it?
No, I think Dustin covered it pretty well. I think the idea is one of the things I like to think about with kind of the technology we're working with is a lot of the stuff, for example, like I work on, I think of as almost like plumbing. It's essentially like, how do we ensure that we can build these kind of accounts in a open and decentralized way? But for a lot of end users, they should really not have to know or worry about that a lot. And so when they run into those friction points, such as having to do token approvals or the gas, especially for people that are newer to like crypto technology, it can be confusing and it can kind of be sometimes scary. Like, why do I have to do this? Why do I have to go set up an account on an exchange to buy ETH? Like, I don't, when I go and use Google or one of my social media apps, I just log in and it works. I can post. I don't have to go and get approval, or not approval, but go get resources from some other place to post on, say, a video on TikTok. And so part of what we're trying to do with account abstraction is abstract that all away so that we still have the benefits of having, say, like a blockchain with fees to essentially write to this public database. But we want to make it really easy and seamless for people to be able to do that and participate, so they can have those benefits of UX, but they still get a lot of the security and decentralization benefits that we want to have as part of that.
Yeah, thank you. That was awesome. You guys are doing a good job explaining this. I already feel like I have a better idea how to wrap my head around all of this. It's funny how you can understand something, but then when you hear other people explain it from different perspectives, how it all comes together in sort of a neat little package. which is important because this is a confusing topic because we're bringing together so many other terms, other aspects of Ethereum in order to be able to really get how this works and why it's so important. So we've got an idea now of why we, as an Ethereum community, have been working towards making some changes. So the way that we are looking at doing this with account abstraction and smart contract wallets, they help in a number of different ways. So why don't we talk about how these smart contract wallets help and what the different pieces of that look like in terms of like gas sponsorship and gas abstraction. Jake, do you want to get into the details on that a bit?
Yeah. So normally when you do like an Ethereum transaction, you essentially have to provide, what you want to do, the signature around that, as well as like the range you're willing to pay fees. So you'll have things like the base fee, which is set by the network. You'll have like your tip you add in for the validators to kind of pick up your transaction and all these things in that transaction. And so normally, and regardless of whether you are doing a normal EOA transaction or smart contract account like transaction, or in the case of 437, we call them user ops, you're going to end up paying Ethereum gas to the network. However, there's one of the classic solutions that people have used for this have been like gas relayers. So you'll essentially have a series of contracts that will like sponsor transactions or those meta transactions and allow you to do things such as use USDC or like a stable coin to pay for those gas fees. And there's some intermediary that is essentially like doing that for you. For, I think, a variety of reasons, those relayers are not widely used anymore because it does add some extra gas, especially on like mainnet, but also due to, I think, some other complexities. One of the things that we do within, say, 4337 is Dustin mentioned there's this idea of like a paymaster, which is essentially a contract that under certain conditions is willing to essentially pay for on behalf of you with Ethereum. And so that paymaster might be something like, say, a stablecoin paymaster, where it is willing to sponsor your transaction with ETH if you are willing to give it essentially a certain amount of USDC at some rate. And so one of the cool things we can do with that then is if someone comes in with a new account and they want to participate in the ecosystem, but all they have is, say, stable coins in their account, they can essentially ask one of these paymasters to sponsor them, and to they can all use basically just the stable coins that are in their wallet versus having to have Ethereum. The other really cool thing with paymasters, which is really good for onboarding and also for other things like games, which have a lot of smaller transactions, for example, is you can actually completely sponsor the transaction as like a DApp or as like a contract. So if I see that, like, say, someone is calling into my contract for my game and they're calling these, allowed functions, maybe I allow, certain amount of interactions per month that I will just pay for on your behalf. So you could come in with an account that has nothing in it. And as you're playing the game and collecting, items, or you're establishing some sort of reputation, when you're getting started doing that, I might just pay for you to do all of that. And so you as an end user don't necessarily have to do anything. You can come into these applications and use them just like you would like a Web 2 application, where you can kind of just get started from scratch without a lot of effort or work.
So quick follow-on question to that, Jake. So it sounds like Paymaster frequently probably would be maybe the project that is building the dApp, maybe not necessarily, but that would make sense. How do the paymasters know maybe if a stable coin is pegged, what its price is, or maybe if there's another ERC20, is it kind of up to them to sort of run their own oracles or understand how much of whatever given stable is equivalent to how much ETH, which in turn, of course, is converted to the gas?
Yeah, so basically it's up to that paymaster to decide what that is. And it may, there are some limitations with the paymasters in terms of like when and how you're going to be able to, say, update those rates, or what you're going to be able to do inside of that flow. But in general, it's really up to the paymaster to decide when it wants to and does not want to sponsor something. So you could imagine, for example, a case where, like, let's say the price of Ethereum is rising or falling rapidly, and you essentially post a transaction that's using a stable coin and it kind of gets outside of those bounds. well, you're likely going to see that operation then fail at the rate you've essentially set or what you've submitted. And so what you would do in that situation is you would just resubmit with the newer rate, just like with a normal Ethereum transaction, right? Sometimes gas fees will rapidly spike and your transaction will be in the mempool, but it will basically like start getting pushed out of that priority queue because there are things that are paying more that are going to go in. I don't remember for Ethereum, there's generally ways we would do something like a child by like replacement transaction, I believe it's called, where you essentially can like override that transaction with a newer one with like updated gas fees. And in the case of like a user op, for example, the 437, you would probably just see it fail and you would just resubmit, say, a user op, perhaps like a different nonce that would have that new rate inside of it.
Awesome.
So
Thanks for
it'll
the
be like
overview.
it'll be like RBF replaced by fee or something like that, right?
Yeah, sorry, replaced by fee. That's correct. That
Yeah.
would be how
Yeah.
you do it with like a normal transaction. Yeah.
Oh, and the beauty of like, account abstraction would be like the user hits retry and then you do the, the nonce increment and stuff like that for them.
Yeah, exactly.
Any of
Before-
the individual sort of use cases we're talking about and improvements alone is cool, but it's like one thing that occurs to me is like when you kind of view it in the aggregate, it's a kind of a step function in terms of usability. It's a little bit like, we used to have our old school phones where you could maybe play Snake and call your mom, and that was it. And of course, then we had smartphones, and this is a little bit sort of in that same direction. It's pretty cool.
Yeah, and you know what, I want to also go, I know we've said EIP 4337 a little bit. I wonder if, Josh, you could back us up, and we've had a live stream before on what EIPs are, so I can link to that in the notes. But if, Josh, you could just explain briefly what an EIP is and why we keep saying the number is 4337.
EIP is the Ethereum Improvement Proposal. It is a methodology used inside the Ethereum community to propose changes to the network, to different components of it, or even different processes that the network does, like the EIP process. So 4337 happens to be a document in debate right now that is, describes a certain issue, outlines how it will be resolved, and the community uses that kind of as the roadmap to decide on that discussion and then how to kind of implement that discussion down the road.
Yeah, and I really like this in relation to what Kent just said with the smart phones that we use now versus, the old flip phones when we were all playing Snake on our phones. EIP 4337 is an example of an improvement proposal. And so what we don't see behind the scenes at a place like Apple or Samsung for Android phones is they're making these improvements. Things are happening along, but in Ethereum, we've got this community and we can publicly see what the developers and community members are working on to move this forward. So whereas in, the phone example, suddenly iPhone comes out with iPhone whatever, and it's like, oh, what are those updates are going to be? Or what are those updates going to be? But with Ethereum, we get to sneak in, take a peek inside ahead of time, vote, have opinions on it, and work together as a community to push forward these new things. And sorry, I keep saying EIP and it's ERC. Justin, did you want to?
Yeah, so the thing about EIPs and ERCs is that there are ERCs that started as EIPs and became or vice versa. ERC is a request for comment, and then EIP is improvement proposal. There are slight differences between them, and I think Josh Jake can tell us more about like the differences between EIPs and ERCs.
Yeah, so I think the main way to think about it is ERCs are basically EIPs, but generally ERCs are application level specifications. So, for example, the most recent hard fork in Ethereum had EIP 4844, which is proto-dank sharding, which was a protocol level change. So we had a hard fork to actually change the Ethereum protocol to implement that. In ERC would be something more, say, like ERC 20s or 721s, which are tokens and NFTs, which did not require protocol changes, but are widely used specifications that applications use to interact with specific contracts. And so one of the big things with ERC 4337 is an application level change. So it does not require a hard fork on, say, mainnet or say like on a rollup. It's something that can be done independent of that.
And just to add on to that, so EIPs and ERCs used to live on the same GitHub, but there is now a proposal about separating them from different GitHubs because of what you said. They're dApp specific versus like core protocol specific, and they would kind of go through maybe different maintainers and different groups of people approving it. So where they used to live in the same GitHub, it actually makes a bit of sense, although there's some friction in the discussion of separating them into different GitHubs just so that they follow a different flow, because the end users of those ERCs and EIPs are actually different sets of developers in a way.
Okay, cool. That was helpful to go through it again like that. So to circle back to what we were talking about before, it was how smart contract wallets help. We talked about gas a little bit, gas abstraction, and did we talk about paying with other tokens as well yet? Did we get to that? Yes. What about account recovery and key rotation and things like Deadman Switch and ZK? We didn't talk about that yet, correct? Should we get into that a little bit? Who wants to jump in? Jake, you wanna, or Dustin,
Before we
wanna do an
get to
intro?
that,
Yeah,
before
go
we
ahead.
get to that, I actually want to talk about like transaction batching as well, because like part of what we talked about with the approval flows was that, you got to approve a token, you do the swap, and then the approval is left open. It could be a vulnerability. Another thing you could do is transaction batching, where you do multiple transactions and you can do them as one, and then you pay the fee, and account abstraction can allow you to do multiple transactions in one. So it is possible to, it's not atomically, but it's kind of like in one go, you approve, you do the swap, you unapprove, and then you don't have this, this loophole that's open and an approval that could like bite you in the end. So that's another way that, it can improve the experience rather than you do 3 individual transactions. You're like, I know I want to approve, I know I want to swap, and I know I want to log out, the equivalent of a log out of the approval.
Yeah, thanks for talking about that before we get into the recovery, so that we know kind of what some of the other benefits are of using this new technology. So what about the account recovery side of things, or did you have anything else you wanted to add, Jake, about transaction batching before getting into the account recovery?
No, I think Dustin covered it very well.
Okay, great.
Yeah, we can jump into recovery. That's actually the main area of my work currently, is
Okay.
focusing on that. So one of the cool things we have with smart contract accounts is because they are, software and we can change things about them. One of the things you can do is you can update your keys. So you can imagine like cases where you maybe expose your key, or you lose it, or you're migrating to a new device, and you would like to, migrate to a new set of keys on that device. Normally with an externally owned account, you can't do that. And so, but one of the things you can do with a smart contract wallet is just do a key rotation. You can actually, if there are similar concepts in like, say, the internet web 2 that we use all the time. Like, for example, the little lock icon you have inside of your like HTTPS website. The certificates that are behind those get rotated usually about every 3 months. And that is essentially a key rotation where you are essentially updating the certificate to like a newer key for some duration. And that makes it so in that case, you essentially have like this window where it's valid. And if someone was to get access to an older key, they would not be able to spoof that website. In a similar way, we can also update or rotate our keys on that account. And there's a variety of ways we can do that. Both like simple ways where you just have like one account that like say is able to rotate that key, or more advanced patterns where say we have social recovery. So for example, I could set up an account with everyone in this call, and I would need say maybe 2 out of 4 of you or some threshold of you in order to have that rotation. A lot of the things we're looking into now are there other ways we can authorize those? Like, can we use email essentially almost as like a password reset to be able to rotate those keys for people that maybe want to have people that help with that, but that aren't necessarily like crypto native users. And I'm trying to think if there's any other ones. I'd say the big one though right now is social recovery. Yeah.
So
And just to add on to this as well, like there are ways to constrain, because like what we're used to is we're used to like multi-sig, which is like, you know, maybe 3 out of the 5, and then you have 3 out of 5 signature, and then you can transfer funds. It's even possible to go the 3 out of 5 is just for recovery, so it doesn't give them the right to transfer funds. It's only when, like, you know, I've lost my key, I need to recover it. The 3 out of 5 doesn't allow them to spend the funds, it just allows them to recover the key to you. So you can even constrain the logic, so it's not as all or nothing as a multi-sig might lead you to believe.
And should we get now a little bit into MPC and account abstraction? And maybe Jake, you could just start with explaining what MPC is and how it differs from account abstraction. We're talking about multi-party computation, so maybe we can get into that a little bit.
Yeah. So MPC accounts, multi-party computation accounts, essentially on-chain look exactly like externally owned accounts. But what you can do with them is off-chain, you can add, you have essentially more complexity or flexibility in terms of how you are managing that account. The most common thing would be like you would have, like, say, a multi-sig MPC wallet, where you essentially would collect signatures off-chain and then broadcast them on-chain as if they were just, say, that EOA. And so you get some additional kind of like privacy and like two thresholds off chain that you can then apply there. One of the issues I've seen with MPC in terms of what is currently being used is the solutions tend to be pretty complex and they tend to be very proprietary. At least the last time I looked into them. And so and also you can't do things like coordinate on chain for things like signing transactions or for having like approvals be posted on chain. So you have to do all of that off chain. And there's some other trade-offs with those as well. So there are some similar aspects to those, but they tend to be for really complex or specific scenarios. I could imagine being very useful for people doing those. But for a lot of more common use cases, it maybe is not as applicable.
Thanks for clarifying that.
Yeah, appreciate that.
So basically what it is that the multi-sig, or rather smart contract wallets, all of the functions and the signature aggregation, whatever it is, happens on chain. I mean, if you're talking specifically about multi-sig, whereas with MPC, the logic would be off chain, and then they would appear as an EOA, or would it basically be an EOA?
It basically is an EOA, from my understanding. And so the thing to clarify too with the smart contract like approvals or like aggregation of like say signatures, you can do that either on chain or off chain. It's really up to you and how you implement that. That's part of the key thing with the abstracting accounts, is we're going to talk about, say, maybe specific ways we might do something. But the general idea is you should be able to do, as a user or developer building these things, whatever you want. It's abstracted away. It's up to you to decide within these specifications or parameters how you want your account to work. And so how you end up, like, say, would collect those signatures, could be off chain, could be on chain. It's really up to, it's implementation specific.
And currently people like, it seems like this, it's not, it's a, let me try to ask the question I'm trying to ask. Okay, so people who want to be able to have more flexibility within how they're using their accounts, if they want to batch transactions, things like that, with smart wallets, is it possible for people that are not super technical, non-developers, to be able to use these tools in a way that is a lot more simple? Is that kind of the goal of this, so that users that are not devs can come in and say, okay, I'm going to batch transactions, or I'm going to do this and this, but I don't have this, coding, deep coding understanding. This is for like the everyday user, right?
Yeah, I would say that there are probably certain aspects of that that are more technical and would be something
Okay.
you would expect like a wallet developer to implement
Mhm.
for you or to interface with to simplify for that.
Okay.
Um, but that gets kind of into another subject, which is the idea of having like plugins or modules for smart contract accounts. So, for example, working with 433. So, to give an example of how that works now, Safe is a smart contract account that's been on Ethereum for a long time. A lot of DAOs use it for their treasuries. People use it for personal accounts, etc. You can add modules to a safe, which essentially is you saying, hey, and also other smart contract accounts that are currently on Ethereum, hey, I would like for this other contract to have control over my account. Um, and so within, say, 437, we have some more robust specs. The two main ones I know of right now are going to be ERC 7579 and ERC 6900. And these are essentially ways that you can add functionality on top of your account for a variety of things, which can include like having different ways to validate user ops or transactions, having flows where the module is able to recover your accounts, having modules that say are allowed to do session keys. So if you're going into a game, for example, you might have, say, a key that you would authorize for that game that's available for some amount and so for some duration, and you could have that as a module on top of your account that is able to like do that. And so one way you can think about it with like current tech is like a lot of people use like Chrome and Firefox plugins you install in your browser that extend the functionality of your browser. You can think a lot of smart contract account modules as being similar to that, where you essentially maybe have some well-known modules that are audited or like a lot of people use that you can essentially ideally plug and play into your existing account that complies with those modular specs.
Okay, cool. That was helpful. Thank you. One of the things that you talked about too, Jake, was gaming a little bit. And right before we got on this call, I was asking Josh about a few questions related to this. Is there anything you want to add, Josh, about gaming and how it will benefit gamers and, in-app?
It's definitely going to both benefit the game studios and the gamers. 10 years ago, when this technology didn't exist, basically someone comes to our website and wants to play our Web3 game, and we are like, hey, do you have an ETH? And they say no, and we're like, go away. Like, why are you here? So this that onboarding experience now where you can come and not have these assets and be invited into that world is a significant improvement. But it does help things beyond that too. Because we can add different permissions into these abstracted accounts. I can have one player account that has access to all of my different game assets while still maybe limiting access to the rare stuff. Let's say, like, okay, my phone can't move the game's core resource because that's very sensitive, but it can go in and do actions on my player or something like that, or perform attacks. So being able to do kind of fine-grained permissions on one account with all these different devices behind it, different keys behind it, can be really beneficial to the games. Going one step further, that also means that me and friends can actually share different assets with similar kind of fine-grained permissions, which becomes really interesting. It means that services can maybe, slightly access my account to perform actions on my behalf while I'm not there, without, again, having access to move all of my assets around. So there's lots of incredible stuff that this can apply to in the gaming world. And it'll be fun to see what people do with it.
Josh, I'd like to actually add on to your example with a physical example. So I have with me a couple of locks and keys. And so you can see here, I have like a smaller lock. It's pretty simple. You'd use it for, say, like a locker in school or something. And I have a pretty simple key for it. And so, using this key, which might be something like a key I have stored in a browser on my phone, or maybe as a third party, I have this tiny key, and it's allowed to use this tiny lock to essentially access things, but it might be very limited in scope in terms of what it can do. For something I have like maybe in games right now, is the highest tier item, is it purple, or is there like a gold or orange that's higher in terms of like the epic loot?
I'm not sure.
Okay, let's go with purple.
Let's go
I think
purple.
those are usually
Let's go
purple.
purple.
Yeah. So let's say then for all my purple items, I need something more secure because I have this awesome item that I've been grinding for. I've done tons of raids and I like don't want anyone to ever take this from me. Well, I might want a better lock. So this is like a hardcore like bike lock. And then I have a separate key for it. And so you can think of like, even though the smaller lock might be something like a, browser extension you have or something on a device, this might be something like an actual hardware wallet that you have completely separate. That's like a cold storage thing. And so the only way you can ever do anything with that item as far as moving it is having access to this specific thing. And so you can essentially change kind of the amount of security you want around that account. And that also plays into the account recovery. So for example, when I start out in this game, I probably have nothing. And so I'm totally cool using a smaller lock to manage all of my stuff. But as I get better at the game and maybe I move up in the ranks and I accrue more reputation or things, I might be concerned that that's not secure enough. So I might add a bigger lock. I might have multiple locks I need to do, or I might even have, let's use this one, different types of keys, such as like this is an NFC card along with a lock. And I might need some amount of like multi-factors to get in or combination of these to do. So maybe I need one to do basic gameplay, but I need say 2 of 3 to move more high value assets.
I love that. That was a great example. It always helps to have a visual to see, because when we see those locks, it's very clear why we might want a stronger lock. It's also the ability to change the type of security is pretty fascinating. So we've talked about how smart contract wallets can help with gaming, gas fees, account recovery, and transaction batching. So we've got kind of a good idea of how it works and what we can do to improve user experience. And why don't we talk a little bit now about some of the roadblocks that are coming up when we're talking about smart contract wallets. So do you want to jump in, Jake, to some of the challenges related to smart contract wallets?
Sure. So the main issue is that in general right now, smart contract accounts are almost second class citizens in terms of accounts within the Ethereum ecosystem. Even when you have a smart contract account, in order to originate or post that meta transaction user op for that account, you actually still need an EOA account to do it for you. And this is true whether you're using, say, like a pre-4337 account, such as like a Safe or Argent, or I think there's some other ones as well, or within 437 itself, the bundlers that are collecting those user ops and posting them, the transaction that originates from that bundler is being sent from an EOA. And so that's one part of, you cannot necessarily originate that transaction from that account. The other thing is in terms of how some of those smart contract accounts are treated when interacting with certain, say, like dApps. The two biggest ones are going to be the differences between transaction origin and message.sender and how dApps introspect those. And also the compatibility with signing messages. So I'll go over the first one first. So when you send a transaction into Ethereum, you're going to be able to introspect on that like contract interaction, these two fields, which can be transaction origin and message sender. With EOAs, when you initially enter, they're both going to be essentially the same. The sender and the origin are that account. As you go deeper into contract calls, and I won't get into calls versus delegate calls, but as you get deeper into those, the message sender will actually change if you do a normal call so that it looks like the contract is the callee for that message sender. And the TX origin will always stay that like externally owned account. One of the things with a smart contract account making that same call is the origin, once again, is that EOA, but the message.sender, the contract that's calling in to, say, swap tokens or do different things, is going to be the actual smart contract account that generally will be that message sender. And so a lot of dApps expect that the tx.origin is going to be the actual account address and not the message.sender. And so there's some compatibility issues there. The other one is signing messages. So normally when we sign messages with an EOA, we can use, we essentially are signing it with that key. And there's a way that would be like, I believe it's via EC Recover. You essentially can introspect that signed message and see the account it came from. Well, the most common spec we use when signing things for smart contract accounts and verifying them is ERC1271, which essentially is just an interface on the account that says, for this given signature and payload, is this valid, yes or no? And so a lot of DApps will only check on the account, or some DApps will only check on the EOA path of checking at that address using that EC Recover. Whereas on a smart contract account, you want them to go through that 1271 flow in order to verify those signatures. And so if you don't have that either as part of your front end for your DApp or potentially compatibility lower down in your contracts, it means that EOAs are able to use your stuff perfectly, but then smart contract accounts can fail at certain steps, such as signing, potentially like signing with Ethereum or other like message signing operations.
Awesome. Dustin, did you have anything you wanted to add on or ask questions about related to this?
Not specifically. I think that it's also possibly worth getting into the ERCs that are necessary to get, you talked about account abstraction being a second-class citizen. So not being able to initiate transactions is one thing. There is a patchwork of like EIPs and ERCs that need to pass, and there's RIP in there as well. Not rest in peace, but roll-up improvement proposal. So like what are the stepping stones that we need to navigate and get into hard forks for like full account abstraction to happen?
I guess right before we get there, we can just take one step back to those problems. Is there anything end user can do to kind of recognize when those issues are happening or recognize when they shouldn't try and use an abstracted account with some of these smart contracts? Are these DeFi dApps at least good at publishing like, hey, don't use this? Or is this like a kind of use and pray sometimes?
From my personal experience, it's you kind of just find out in the moment. The way I, as a user, have experienced this is generally if I am using a smart contract account with a DApp and I see like a message sign fail, or sometimes I'll actually see like in my network calls in my browser that there's like a 500 exception from a server that's trying to process something from the account. And that generally indicates to me that there's not support. And the workaround, unfortunately, I usually do now is I have a EOA account that I might have to use instead. And that requires moving funds. It might require some other like work, and then I have to use that instead. So that's kind of, for me as an end user, when I've experienced that, that's kind of the workaround I use now. Ideally, we would have over time, more applications and contracts just be compatible.
Are you using abstracted accounts primarily right now? And if so, is it like a 75% of things work, or where are we at?
I would probably say it might be closer to 80 or 90% for the stuff I use. So it's most of the major apps I've used, they all work fine. Like I've used Uniswap. What else have I done? I believe OpenSea works, and most NFT marketplaces work with those as well. Because I mean, safes are a pretty common existing account that a lot of individuals use for those things. Most of my core accounts are all smart contract accounts, and I basically have the EOA and a couple others for like developments that are mainly just for compatibility and like just that things that are holdovers from before I had those. So I would say I'm attempting as much as possible to dog food, what we work on in the ecosystem.
A quick follow-up question before we dig into some of the stuff Dustin was talking about. What does this look like, Jake, in the context of rollups specifically? So, of course, what we've been talking about is relevant and built on Ethereum mainnet, but hypothetically, it seems to me that any EVM compatible chain can adopt the very same tech. On the other hand, I know Starknet, it's not EVM compatible, but it was doing very similar things inspired by account abstraction. But yeah, what does it all look in the L2 context, which I think is important because more and more liquidity, more and more users are flowing over to L2s as was designed by the scalability roadmap of Ethereum.
Sure. So one of the cool things layer twos can do, and I think one of the things we want them to do, is they are able to kind of experiment outside of the EVM spec if they want to. There's no reason why you can't have a rollup that is not using the EVM at all, but still is rolling up its state into the EVM on like in a contract on mainnet. And so a number of L2s, I believe, including Starknet, essentially have their own versions of native account abstraction that looks very similar to a lot of the things we have as part of the EVM, but there are slight differences or spec differences in terms of how those things work. But at their kind of core, they have probably more things that are similar than different. For chains or rollups that want to be completely EVM compatible, what we have kind of right now is you can essentially, ERC-437 has contracts deployed across a wide variety of chains. And so at that application level, you're able to adopt those without any changes to the underlying like EVM or functionality there. But there are proposals such as, and I have to look this number up, it's RIP, which stands for Rollup Improvement Proposal, 3607? No.
Is it 7560?
7560, that would be it. Which essentially would be enshrining the 4337 spec at the protocol level. And one of the thoughts is that with rollup improvement proposals is there might be certain things that rollups can adopt and use even ahead of maybe them being adopted as part of the EVM in general to have additional or improved functionality. This is from my understanding. And so you kind of have these like different like protocol level account abstraction, which say Starknet and other L2s have built in. And then you have kind of more application level account abstraction, which would be something like ERC-4337. And so the biggest difference between those is, do you need to change the underlying execution protocol and sometimes consensus to handle that versus just being able to pull in a specification and use it as is on like a EVM rollup.
Awesome. Thanks for the overview.
Yeah, it was great. Any other questions on this, or should we go back, Dustin, to what you were asking?
I have a diagram that I'll just screen share, which I think helps.
Okay.
Nice.
So just, do you want to walk us through it, Dustin or Jake?
Maybe Jake can walk us through. I mean, no, I know what it says, but I think Jake can probably delve into the details of like what that means.
Yeah. So obviously we have our EOA, which we talked about, which is, as I think in my head, more like hardware-esque. It's kind of set, and it's the kind of traditional blockchain account that you would use, and the original one you would use, say, for Ethereum. You have smart contract wallets or accounts, which you can have a lot of flexibility. You still need an EOA to initiate it. And there's, as I mentioned, some compatibility issues with kind of that are present. ERC-437 is an extension of that, where you still have to have that initiation by EOA, but you have that arbitrary execution logic, and you also have the biggest thing ERC-437 does is it prevents a lot of like DDoS style attacks on the like bundler networks and other places where we're allowing this arbitrary validation and execution logic to work. And it has a number of ways involving staking and throttling that it uses in order to kind of prevent or mitigate those kind of larger scale attacks. And so it kind of adds some additional things on top of that. Native AA, which would be something along that RIP I mentioned, or some other EIPs that are in progress, is you essentially have all those things, but you can also have that native smart contract account be the origin of that transaction. So you don't need a separate EOA to post the transaction for the on-chain. There's a way essentially that you can essentially just use the smart contract account to do all of that with whatever keys or validation logic you have for doing that.
Cool. Thank you for going through and explaining that. It does always help to have some visuals, I think, to follow along with to see how it works. We're actually getting close to the end of our time. Does anyone have any questions we want to ask before we're done? I know we haven't gotten through everything. Any kind of burning other topics that we want to make sure we discuss ahead of time? by ahead of time, I mean before our next session, because we're going to do a follow-up on account abstraction as well. But Dustin, I know you had some other topics in the agenda. Anything else you wanted to get to?
I don't think they're topics that you can get through in 5 minutes, but I think that the reason account abstraction kind of like bubbled up to top of mind is that recently there was this big furor about like EIP 3074 and the role of invokers and stuff like that. Like what does an invoker mean in that context? And I guess we'll have to do a really quick run through of like what EIP 3074 does.
Sure. So 3074 essentially allows a EOA to kind of delegate to a smart contract account via like an invoker, via 2 new opcodes that essentially allows that smart contract to act on its behalf. But in terms of what is seen on chain is going to be the actual EOA address. And so one of the key things with with that invoker. And so this essentially would allow a EOA to function as if it were a smart contract account and potentially get the benefits of things like batch transactions, gas abstraction, not key I don't believe key rotation. One of the things with 3074 is you actually keep the original keys as part of that account. The other big limitation is we didn't discuss this very much, but the way smart contract accounts and EOAs work across chains is significantly different in terms of EOAs kind of work as is across many EVM chains. Smart contract accounts you generally have to deploy per chain and also configure and recover per chain. And so even with something like 3074, you could say invoke on mainnet that you want to delegate this EOA to this invoker and to some smart contract account. But you would have to do that also, say, if you have the same account on a rollup or another EVM system.
Yeah, the cross-chain experience is actually quite tricky with smart accounts. So for example, I have a smart contract wallet, but you're not going to pay fees to deploy it on every single chain. But part of the reason that you might want to deploy on every single chain is so that you have the same address on every single chain. And if you don't, then there's the potential that someone thinks you have a contract deployed on, let's say, for the sake of argument, Arbitrum, and maybe you've only deployed on Optimism. So someone sends you something to your address thinking, oh, you've probably, they think it's an EOA. The assumption most of the time when you give people an address is that it's an EOA. So they'll send it to whichever chain it is. But if it's a smart contract wallet, you can't make that assumption because you may not have deployed on that chain.
Yeah, one thing I'll mention with that as well, like obviously that is a frustration or it's a friction point for having that adoption, but there actually are benefits to that as well. So for example, if I have an EOA that's across multiple chains and I have assets on that across multiple chains, if I lose the key for that or it's compromised, that means I'm compromised across all of those. And the same would be true if you did the same deploy of a smart contract account, the configuration of the keys across those chains. One of the things you can do is also just have different accounts for different chains. So I know that like my mainnet account is going to be super secure. And so I'm going to have something for that. But maybe my account on a rollup is just for like my spending money. And so I'm going to have, less on there. And that means that if I lose the key or it's compromised on that rollup, I only maybe have a limited amount of risk or things that can be lost on there. Whereas because my mainnet account is different and more hardened, it is still safe, even though I lost the keys for that other account. So even though it does add complexity to kind of the configuration and management of those, it also does provide some advantages where if you do become those keys become compromised, you limit the damage that can happen to the assets you have.
That's a great point.
Awesome. Okay, I think Kent had to drop off because we are actually at time. And so this was so great. Jake, thank you so much. We really appreciate you sharing your brain with us today. I learned a lot. I hope everyone who's watching learned a lot. And we will talk to you soon. And thank you all for joining, listening, and take care. Appreciate it.
Thanks for having me.
All right,
Thank you.
bye.